to welcome Steve Ackerman, who's going to be presenting the wreck of the Edmund Fitzgerald, the ship, the storm, and the song. I saw Steve's presentation about a year ago in Lake Mills at the Lake Mills Library, and when I saw it, I said, we got to get him for the History Roundtable. So I think you guys are in for a real treat tonight. And actually, I follow Steve. Wisconsin State Journal always has an article every Monday morning about the weatherman. So I always follow that. I actually get the paper as one of the first things I read on Monday morning, like, what's going on? What's the topic with the weather? And, we all complain about the weather, but, but we got to live with it. So anyway, without further ado, let's welcome Steve Ackerman.
Hi, thank you, everybody. Yeah, boy, nice crowd here. First, the other thing I want to say about, we're known as the weather guys, not the weatherman. It's me and John Martin. If you have any questions that not are associated with the Edmund Fitzgerald, send them to me or or come up and ask me, and then we'll put it on in the Monday paper there as well. So yeah, I'm going to be talking about the sinking of the Edmund Fitzgerald, this historic event, from the perspective of the ship, the storm, and the song. This legend of the Edmund Fitzgerald, it's part of Wisconsin and the Great Lakes history, as we can see, and that's why I think a lot of folks are here. I think the story itself is only exceeded by one other shipwreck, and that's the Titanic. And I think personally the Edmund Fitzgerald is a much better story because we don't know how the Edmund Fitzgerald went down. And I'll talk about some of the theories as we get through this talk. But the other thing to always remember in your mind is there were no eyewitnesses and there were no survivors. And so that's why there's still a lot of argument about what actually brought the ship down, or how did it go down, is the big thing. Of course, the other thing that helped spread the story was the Canadian folk singer Gordon Lightfoot. He read about it in the Newsweek article. He was working apparently, I just learned this the other day, on an Irish ballad. He was taking some music and adapting it, and then when he read about this in the Newsweek's article, he wrote the words to it, and it came out shortly after that as the wreck of the Edmund Fitzgerald. So what I'm going to do is talk a little bit about the ship, a little bit about the song, and a little bit about the storm. And then we'll integrate it all together and look at the last 3 days of the Edmund Fitzgerald and how those three things interweave and represent themselves. As far as the ship, as we all know, we just celebrated the 50th anniversary. I seem very odd when I say celebrate that anniversary, right? We memorialize that sinking 50 years ago on Lake Superior. As I go through this, as I said, it's a really interesting mystery, but we also important to remember that 29 sailors lost their lives during that disaster. And those 29 lives go beyond that number 29. It rippled out to the lives of all their families as well. And at the very end, towards the end of this, I'll list those 29 sailors, what their names were, what their age was, where they were from, and what their job was on the Fitzgerald. It was the worst shipping disaster on the Great Lakes in 10 years. There's been some, I hate to say it this way, but this is some great disasters on the Great Lakes. But this is the last one, and it was the only one now. There hasn't been one since that time, and part of that is associated with the changes that have occurred since that ship went down. The Fitzgerald, again, in terms of some of the statistics, it weighed 13,632 tons. When it was built, it was the longest ship on the Great Lakes, and they built it as big as they could in order to get through the Sioux Locks and through the causeway there, the water causeway in New York. I should remember, this probably recognized, yeah, the Seaway, the Lawrence Seaway, to get to the oceans. It never really did a lot of work in the oceans, but just in case. It was launched on June 7th, 1958, and about 15,000 people showed up to see that launch. I mean, that's how interesting that ship was. That's how popular that ship was, that many people showed up to see it. And because of that, it got a lot of nicknames: the Fitz, the Big Fitz, the pride of the American flag. And because of that, because it was built so big, it set a lot of records in terms of the tonnage of the iron ore that it would carry. And a lot of times, as it broke a new record, it was actually breaking its previous record as well. In this boat, the reason why I like to show this picture, this is obviously the ship. It has 3 cargo holds that these pellets would be loaded up into. There are 3 separate ones. They would be loaded through these 21 hatchways. So those covers, you'll be hearing me call them hatch covers. So they would roll the pellets down through each one of those 20 hatchway covers until they've got enough load in there, and then they would move on to the next one until it was filled up. And by filled up, it doesn't necessarily mean it went all the way to the top. It went to the weight that the boat could handle. The storm. During 9th and 10th of November 1975, we had one of those nasty November gales that ravaged the upper Great Lakes regions, with winds blowing between 55 and 63 miles per hour on Lake Superior. And every now and then I'm going to come back to 1975, what it was like then, and I see by the color of the hair of people in the audience, or the lack of hair, that we were all, learning to drive or just starting to drive. And to go 65 miles per hour was pretty fast, right? So that's the kind of wind that we're dealing with. November, in terms of the Great Lakes, and in particular Wisconsin history, has produced some memorable storms, one of which is the White Hurricane of November 7th through the 10th of 1913. That killed over 200 people who got caught out in that storm. Also in 1940, the Armistice Day storm, November 10th and 11th, that killed over 50 duck hunters in Wisconsin, and another 40-something in Minnesota next door, and it took down 3 ships on Lake Michigan. And we'll see, and that ship had 29 sailors. Those 3 ships had about 29 sailors on them as well. And as we'll see, this Armistice Day storm was very similar in terms of character as the storm that sank the Edmund Fitzgerald, not only in the date, but in the weather that actually occurred as well. So it's very reflective of that. After the Armistice Day storm, there were changes in how we did weather forecasting and distributed it, and the same thing happened since the 1975 storm. And of course, the song. In 1975, Gordon Lightfoot read the Newsweek magazine article. It was part of this article called "The Cruelest Month," November, the cruelest month. Come on, clearly he's one from Wisconsin. It's just normal. But he read it about the destruction of the ship, and then the next year he released his song, "The Wreck of the Edmund Fitzgerald." It became #1 on the United States Billboard chart. Number 2 on the United States Billboard chart. #1 on the Canadian Billboard chart. And you might remember that he's Canadian. Little bias there. And it continues to be played on. So if you listen to our old rock stations like myself, you'll hear it every now and then. And he's actually, as we'll see, has changed some of the words, although you won't hear the new words on the radio. All right, so those are the 3 little introductory things. Now let's start looking at the whole thing. We'll look at the words of the song, what was happening to Fitzgerald, and just as important, what was happening to the weather. I'm not going to sing these. I'm going to try and do it with a beat, but my voice is not really a singing voice. And so when you see italics like this in quotes, this is coming directly from the song. The legend lives on from the Chippewa on down of the big lake they call Gitchigumi. The lake, it is said, never gives up her dead when the skies of November turn gloomy. With a load of iron ore 26,000 tons more than the Edmund Fitzgerald weighed empty. Overall, I think the song is pretty accurate of what was going on. I had a little debate this past weekend with another author of a book that just came out, and he thinks that it doesn't get it at all. I'm just saying that so you know, I think it's actually pretty good, although there are mistakes, and I'll point those out. One of which is the Ojibwe called Lake Superior Gitchigami, meaning be a great sea, which I think is so much more descriptive of Lake Superior than Lake Superior. Right? It's telling you what it is. It's a sea. You probably know I'm not a native Wisconsinite, although I consider myself Wisconsinite. I try to argue that with my brothers. I try to tell them I lost my New York accent, for example. And that's what my brother does. He laughs and just said, "You just ordered a coffee." He called it Gitchigumi because in the Newsweek's article, that's what they referred to it as, and also in Longfellow's poem about Hiawatha, he also then calls it the Gitchigumi, and I think that's why Gordon Lightfoot used it that way as well. The lake, it is said, never gives up her dead when the skies of November turn gloomy. Doesn't matter if it's November or not, the lake is not going to give up its dead. When somebody drowns in a lake, there's biological activities that do decomposition, that generates gases, and those gases float the body to the surface. The Lake Superior waters are too cold for that biological activity to happen. So those gases are never generated and it never floats to the surface. With a load of iron ore 26,000 tons more than the Edmund Fitzgerald weighed empty. I always have problems with these numbers. 26,000 tons, how heavy is that? So to put it in my perspective, that was enough. They would take that iron ore and they would make 7,500 automobiles. That's where it was headed. And remember, that was 1975. So we're talking like Galaxy 500, Ford, those big cars. That's how much ore was in that boat. As I said, it broke a lot of records during its era. Actually, there's one thing I forgot to point out that'll come important. So I just wanted to come back to this slide. With the hatchway covers here, they weighed 7 tons each, and so when it was loaded up, they would have to take something up and put the hatchway covers on, and then the crew would have to clamp down 68 clamps around each cover in order to seal it and keep it in place. And again, this will come up when we start talking about why did the ship go down. By the way, if you've never seen taconite pellets, I have some right here. I'm going to give them to this young gentleman right there to pass them around if you want to see it. If you don't see it, come on back later, and at some point we can see them. And if you want to steal one or two, feel free to do that as well. But that's the load. And the nice thing about them is when they were loading those hatchways, they would just put them down a slide. They're like marbles. They would just roll right down there. You can fill the ship up really quickly. The ship was the pride of the American side, coming back from some mill in Wisconsin. As big freighters go, it was bigger than most. It's bigger than all of them when it was first built. Eventually, 729 feet long. Eventually, they built a 1,000-foot ship as well. But when it was launched, it was the largest. And it wasn't coming back from some mill in Wisconsin. But that's okay, right? It's we got to give artistic license. That's fine. When launched on June 7, 1958, from River Rouge, Michigan, it was the largest ship to be on the Great Lakes at that time, and she remained the largest until it sunk. When they did launch it, as I mentioned, 15,000 people showed up to see it, and even throughout the history before it went down, if people had a chance to see it, they went and saw it. And that's what I've been learning as I go around across the state talking about this. People give me their pictures. This is what me and my dad saw when it came through the Sioux Locks, which is great, I think. The other thing, the other thing I want to point out is the USGS. Oh no, the other thing I wanted to point out about the launch. You know, when you launch a boat, how do you launch it? Champagne bottles, right? You break it over the bow. And so when they launched this, the Edmund Fitzgerald was named after the president of the mutual insurance company. And his family had a lot of history in the shipping industry. He didn't want to be in the shipping industry, and that's why he became the president of that insurance company, which owned the boat and built the boat in order to make profit, right, to make some money. Nonetheless, they named the boat after him, and his wife got to launch it. When she broke that champagne bottle across the bow, it didn't break. So she did it again, and it didn't break. So she did it a third time, and then it finally broke. And then, you know, the champagne bottle isn't what to do it. Then they got to knock all the blocks off and allow it to come off. And again, that wasn't such an easy job either. So you can imagine how big and heavy it was. When it eventually did get launched, it went into the dock area and just generated a big wave, floated all the way over to the other side, and hit that side of the dock as well. So, you know, again, we know the history, we know what happened. So when we hear that, oh, they had a hard time launching it and actually bumped into the thing it's not supposed to, makes you think about the history of was it foretelling what was going to happen to the Fitzgerald. The other thing I want to point out is that the U.S. Coast Guard changed the freeboard of the boats in 1968, 71, and 73. In the end, that's about 3 feet, 3 inches. They allowed it to be increased. What that means is you can take on more load. And again, when they do that, the question that comes up, was the boat designed to actually take on that more load? And that'll be another thing that'll feed into the theories of why did the ship go down. Concluding some terms with a couple of steel firms when they left fully loaded for Cleveland. They make boats in Cleveland. They don't make cars in Cleveland. They go to Cleveland. I was going to Detroit. But artistic license. I'm picking out where he had problems, but the song had problems, not all the accuracy where it was. This is the path of the Fitzgerald as it was heading to Sault Ste. Marie, the Sault Ste. Marie locks. And if you look at that, you might immediately ask yourself, you know, because we know 75 fuel was cheap, but it did cost. And so you might ask yourself, why did they take that northern route? It would be certainly shorter to go more southern route, if you can see my mouse that's in there. This, by the way, is where it actually crashed and went down when the ship is sunk. And of course, they initially planned to go that southern route, not the northern route. And as a weather guy, I can probably ask you the question that you know the answer to. And that is, why did they change the route? The weather forecast. So day one, the birth of an extratropical cyclone. So these are the storms that we're very familiar with in the wintertime. They got the cold fronts and the warm fronts attached to them. And in Saturday, November 8th, 1975, it turns out to be a gorgeous day, right? We've all experienced that. Today was a gorgeous day. Right? It was beautiful outside. I was inside working on this talk thinking, I should be in my rowboat, which I launched this summer. On that day, the Edmund Fitzgerald glides on the smooth Lake Superior waters to get its next load of iron ore from Duluth Superior Harbor. This is what it looks like, the weather map. Remember, I'm a weather guy. So what I want to point out here is a couple of things. I'm assuming that many of you look at the weather either in the newspaper or on television. And if you do, the blue lines with the blue triangles, they represent cold fronts. We'll see red lines with half moon, red half moons on them. Those are, of course, warm fronts. They're representing where you have a gradient in air type, which usually means you have weather associated with it. All of these little shaded areas is where it's precipitating. Try and ignore those. What I want you to draw attention to is where are the low pressures, and then these thin blue lines. Those are lines of constant pressure. And what's important there is not necessarily what the pressure is, but what the spacing is. So if the spacing is far apart, the winds are really light. When the spacing starts to get packed, that's when the winds really start blowing. So when I show you those weather maps, have that in your mind. As a weather person, when you look at this map, you may be, if you're not a weather person, thinking, well, where's the nasty weather coming from? If you're a weather forecaster or just interested in the weather, the thing that attracts your attention on this map is this little low pressure system there, just in the panhandle of Oklahoma. And the reason why it attracts your attention is because as meteorologists, we want to know where these storms begin to form and intensify and where they go. And when we did that for the Great Lakes region in the fall, we found a rather interesting result. There are typically two areas where these nasty storms hit the Great Lakes in the fall. The first soar, or as he says in the storm, that'll make the skies turn gloomy. This area right here is the first area where we have cyclogenesis. That's the beginning of these storms. They're getting organized, the jet stream is working up above, and the storm is beginning to develop, and then working with the jet stream up here in Alberta, where it's all forming, it just takes off and just clips the Great Lakes regions. And I've heard, and I know this, and you may have heard that weather forecasters will sometimes call this Alberta clippers. Right? Just descriptive. That's, we like the weather, we like physics, but we're really not, our naming is very conventional. This is the other area that's really important in the fall, where cyclogenesis occurs and it heads right towards the Great Lakes. It's just east of the Rockies, so as these storms move across the Rockies, all of a sudden the bottom drops out as the land goes back out of the mountainous regions, and that stretches the storm. And if you think of an ice skater that's spinning, if they want to spin faster, they get more vertical. And that's what's happening there, right in the panhandle of Oklahoma and Texas. And the way the jet stream is typically on that, at that time of year, the storms that begin to develop head to the southeast for a little bit and then hook right up and head towards the Great Lakes. And we call those, or I call them, panhandle hookers. Think of it as a storm. So those are the source regions. So that's why you can see, when you see that low right in the panhandle region there and the jet stream set up, you start thinking, is this going to be one of those storms that hit the Great Lakes? Day 2 with the Fitz. Early Sunday morning, November 9th. It's in the Duluth Superior docks, and it's being loaded up with enough iron ore to make 7,500 more automobiles. As I mentioned, those little marbles are nice and heavy, and they roll them right down into the hatchway covers, through the hatchways, and into those 3 storage compartments. And then the crew has to anchor each one of those 7-ton hatches with 68 special clamps. Right? So each one of those 20 hatches needs 68 clamps that need to be sealed. And shortly before 2 p.m., the Fitzgerald departs into the open waters of Lake Superior. And it's a beautiful day. But not for long. Because this is what the weather map looks like on 7 a.m. Eastern Standard Time, November 9th, 1975. For those scientists in the office, we typically talk about UTC now, but back in 1975, the maps were written in Eastern Standard Time. So I thought historically I would just keep that tradition, but clearly that's 6 a.m. our time during that day. And what you can see is, this cold front got well developed. There is now a warm front. That whole system is beginning to develop into a storm. If you look at the spacing of those thin blue lines, you can see right around there, they're starting to get packed together, which means the winds are picking up. And if you think about it, where those blue lines are, if you just imagine wind going around following those blue lines, that's the circulation pattern as well. Sunday morning, so it's heading towards the Great Lakes, and that's what it's predicted to do. November 9th, 1975, again, this is a beautiful day. The Arthur Anderson, the captain of the Arthur Anderson, Bernie Cooper, will recall many years later that this Sunday, quote, was one of the special days on Lake Superior. Just ripples on the water, sunny and warm for November. As we departed, we could see the Edmund Fitzgerald. And those two ships are going to sail together. Why not, right? They know captains know each other. Why not? You go into the same place, travel together, stay in contact in case something should go wrong. The forecast. On November 9th at 7 p.m. Eastern Time, the National Weather Service issues a gale warning for Lake Superior. And what a gale warning means that the winds are going to be 40 to 46 miles per hour. They also predict that the winds are going to be east to northeasterly during the night, and then shifting over to the northwest to north by the afternoon of November 10th. So at about 2 a.m. November 10th, the National Weather Service upgrades their gale warning to a storm warning, which means the winds are going to be in the range of 55 to 63 miles per hour. With the prediction that there'll be northeast winds, 40 to 57 miles per hour, becoming northwesterly, and waves 8 to 15 feet high. And around 2 a.m., the two captains are chatting to each other, talking about the threatening weather, and as a result of their discussions, they decide, let's not take the southern route, let's take the northern route, right? So that's why they take that route, because they're expecting winds when they're down here. If they would have kept on those paths, they would have been encountering, based on the forecast, northeasterly winds in the range of 40 to 57 miles per hour. And again, northeasterly winds, that means that's the direction. So if they go further north, they ended up doing two things, right? One is wind coming off the land is going to be lower generally, right? Because the land friction is going to be stronger than it is over the water. More importantly, what they're doing is reducing the fetch, the amount of open water that the wind will be blowing over. And that's going to do two things. That means the winds will be really strong, and if you have a big fetch and strong winds, you're going to have bigger waves. And so by going further north, they were going to reduce their exposure to large waves because of that strong wind. At 3 a.m. on November 10th, the winds were reported as coming from the northeast at 42 knots, which is like 48 miles per hour. The Fitzgerald and the Anderson, again, they're traveling together. The Fitzgerald is ahead of the Anderson. It left port before, and it's got a bigger engine, and so it can travel faster. And so it's always going to be ahead of the Anderson during these last 3 days. They had radio contact, they were talking, and at 7 a.m. the storm passed over Marquette, Michigan, and started across Lake Superior. And if we go back to looking at what the weather map looks like on that day, look at the spacing of those isobars, right? That means the wind is going 55, 60 miles per hour, and it's right over the lake. In a storm system like this, Again, you can see the blue line, the cold front, and the warm front, and the red. And then the purple one is associated with an occluded front. Basically, what all this is saying is the storm is at its most intense phase right now in terms of its life cycle. And this is when the Fitzgerald and the Anderson are out there. By the way, in case people ask later on, some boats, went into harbor and waited for this to go out. But these guys are already committed, so they're out there. And as the song goes, and late that night when the ship bell rang, and could it be a north wind they'd been feeling, right? And what he's predicting here with this song is, they changed their northern route because of the weather forecast. Maybe the forecast was off, and the wind's coming from a different direction. But before we get to that, I have to talk about another 50th anniversary. So the Fitzgerald is not the only 50th anniversary this fall. The other one is the GOES program, the weather satellites. That began in October 1975. And these are the satellite images. This was the beginning. If you look at satellite imagery and track weather, you see these animations of the cloud systems going across the US. This was the beginning of that program in 1975. I like to point it out for a couple of reasons, most important of which is Wisconsin is known as the birthplace of weather satellites. It all began here with a professor, a faculty member named Vern Sumi. He's the one who had the first successful mission on a satellite to look back and take a picture of Earth. And then he moved on as well and was advocating for the GOES satellite program, as well as to build the software in order to analyze this data and to animate it, which the National Weather Service and a bunch of other people were certainly using, not only then, but even now. And this is what it looked like, the satellite image looked like on November 10th, 1975 at 4:15 in the morning, Central Daylight Time. It's the only one that I've been able to find that's actually a really good one to show you what was going on, even though we have the complete, we have all, in theory, all of the GOES satellites going back to the very beginning. And as the song goes, when the skies of November came slashing, when afternoon came, it was freezing rain in the face of a hurricane west wind. Not a weather guy, according to Lightfoot, even though he's Canadian, you'd think he'd know about weather. Freezing rain, I have not yet seen an observation that said there was freezing rain. There was snow, and there was rain, and there was wind, but I haven't seen anything about freezing rain, which you can imagine is really good. If anything could go worse during that storm, it would be having freezing rain, because that would just cover the boats and would stick around. Also in the face of a hurricane west wind, again, as a meteorologist, I have to point out that a Category 1 hurricane has wind speeds, sustained wind speeds of 74 to 94 miles per hour. And what I'm showing you here is that, no, that never occurred. They got nasty. I'm not saying I want to be on the lake on these sustained winds, but when we look at Marquette, Michigan, which is on the bottom, and Sault Ste. Marie, which is on the top. What we're looking at here is the red line here is the pressure that was being observed going from early November 11th, is that 11th or 9th? 9th, out to 11th. And then the black is the wind speeds, the sustained wind speeds that go along with that. And then the same thing up here for Sault Ste. Marie, right? The pressure in blue and the winds in the steady winds in black. So you can see in the steady winds, at best, they're getting up to 40 knots, which again is nowhere near 64, 82 knots for a hurricane. The red dotted line, vertical here, shows you where the Fitzgerald, what time the Fitzgerald went down. And when I talked about the 1940 storm, we didn't have the type of weather service that we have now. We didn't have numerical weather prediction. We had experts trying to interpret that. Prior to the formation of the Weather Bureau, observations, people were making observations since the beginning of history, right? Trying to do weather forecasting by observing what the world was like and then what happened to that weather. So they're more like climate forecasts, but they were strong attempts to do that because knowing the weather was so important. And so a couple of those sayings, one which is very popular, I think, red sky at night, sailors delight. Red sky at morning, sailors take warning. What that's telling you is that in the mid-latitudes, these storms move from west to east. That's what it's saying. Here's another saying, fast blow after low foretells stronger blow. So when you have the instruments to measure pressure, which we had in the 1400s, if all of a sudden you saw the pressure start to rapidly rise, observations told you that the wind speeds were going to pick up. And clearly, that's what's happening here. Although in 1975, we have numerical weather prediction really just beginning. It's only about 10 years old at the time. So there's a lot of stuff we didn't know yet with regard to like, how short can your forecast be in relation to your grid spacing on the map. So there was a lot of things still being learned in 1975. On the afternoon of November 10th, the wind shift was clearly evident. And at 2:45 in the afternoon, the winds had backed to the northwest. And by back, that means they went counterclockwise and were 42 knots or roughly 49 miles per hour. Waves were observed to be 12 to 16 feet. And that was reported by the Anderson. Back then in 1975, I was telling a group back there, there were no weather buoys on the Great Lakes. We didn't have them. The only weather observations that the National Weather Service got were from the ships. And if they had time to do it, they reported it. And they also looked at wave heights and reported wave heights as well. At around 3:30 p.m. in the afternoon there, the Fitzgerald contacts the Anderson. Remember, they're talking. They're in contact all the way. And reports a fence rail down, 2 vents lost or damaged, and a list. And so for those of you who've done any boating, a list means it's tilted, which means it's taken on water. Right? So they know they're taking on water. They know they've had some damage. The vents are those big white things you usually see. That got ripped off, which now means there's holes in the deck. And then the other thing, which sort of surprised me, when I heard about a fence rail down, I kind of thought about these, little picket fences we have to hold in sheep and things like that. Just to want to keep somebody from going there. But that's not what those fence rails are. These are strong, thick steel wires running across. That's what went down. So there's a lot of debate and questions about how the heck do you lose, how does those wires break off? And the general theories are debris blowing over the deck hits them and takes them down, or the ship bending and flexing eventually breaks it as well. Again, we don't have eyewitnesses, so we don't really know. But when you see a fence rail down, we're not talking about these little flimsy fences. We're talking about a big, heavy wire. Also at this time, the storm's fury had closed the Sault Ste. Marie locks. Right? So it got nasty enough that they said, nope, nobody can go through here. And as the song goes, the wind in the wires made a tattletale sound, and a wave broke over the railing. Right? So it's not just a wave that would take the railing down. The wave would have to bring something else that then would float off and take the railing out. So a shift to the west or northwest is very important in terms of the history of the Edmund Fitzgerald and what happened to it. Because remember, they went to the northern route because that's when the wind would be coming out of the northwest or the northeast. But what's now happening is the wind's coming out of the northeast. The wind is coming out of the northwest, which means all of that open water, all that fetch, the strong winds running 55, 60 miles per hour can blow over that and develop waves. And when you look at a wind-generated waves, there are 4 things that can really determine how big that wave's going to be. The one is the wind speed. And when I say wind speed, I mean the sustained wind speed. Otherwise, I'll say gust. You need a strong wind, sustained wind speed. The stronger the wind, the potential to generate a bigger wave. The duration of the wind, right? And that just can't be strong, it's got to last a long time. So if it lasts a long time, that gives it more time to push water around to generate the larger waves. The fetch is the open distance across the water. The bigger the fetch, the bigger the wave, because you can move more water. And of course, the water depth. When you think about the Great Lakes, you're not going to generate 25-foot waves on Lake Erie. Right? But Lake Superior is 500 feet deep. Right? That doesn't become an issue anymore. And in fact, we can actually do theoretical calculations. If you assume that we're in the ocean, it's basically infinite depth, infinite fetch. What then is the wave height as a function of sustained wind speed? And that's what we have here. This is the wind speed in knots, and this is the wave height. This is the theoretical, right? So that's basically as big as they can get for a particular wave of, say, 40 knots. The X's here are observations from different ships. So a lot of ships were reporting 25-foot waves, some of them even 30-foot waves. After the storm, some actually said, well, they were probably 100, but I'm not sure I believe that. I believe what's happening then when you observe it. But you can imagine, 25-foot wave, I don't know, how big is your ceiling, 15 feet? I mean, those are really big waves. And as the song goes, when supper time came, the old cook came on deck saying, fellas, it's too rough to feed you. We'll look at this later on, but one of the things us meteorologists like to do is like what we did, asking the question, where do these things develop and where do they go? We take climatology and we do that. The other thing we do is we like to do hindcasts, right? So we like to take today's model and look at how does that compare to the past. And we've done this. Me and my colleague just did it this summer, but these folks did it in 2006. And what they found was, these storms not only can generate 25-foot waves, what they found in the models in 2005, 2006, they actually predicted the storm more accurately than they did in 1975, which is a good thing, right? We would certainly hope that that would happen. And in fact, if you go back to 1975, the accuracy in a one-day forecast in 1975 is equivalent to a 5-day forecast today. So you can all, give us a hard time about, the only job that you can be wrong at. But in reality, we've really improved our weather forecasting these days. Of course, in the middle of those howling winds, snow, you can imagine what it's like being on the lake with 55-mile-per-hour winds and snow. Something goes wrong. Something, I should say, goes really wrong, right? Because the Fitzgerald knows that has a list, so they got a problem. At 3:30 p.m., Mick Sorley, who is the captain of the Fitzgerald, calls Cooper on the radio and says, Anderson, this is the Fitzgerald. I have sustained some topside damage. I have a fence rail laid down, 2 vents lost or damaged, and a lift. I'm checking, which means slowing down. Will you stay by me till I get to Whitefish Bay, right? That's where they're headed, so they can rest up because Sault Ste. Marie is closed. Charlie, on that Fitzgerald, do you have your pumps going? And the response is yes, both of them, right? So they know they're taking on water because they have a list, they're turning on the pumps to try and get rid of the water. And of course, it doesn't happen. They maintain that list. But something has really damaged the Fitzgerald. The windstorm intensifies, and by 4:10 p.m., gusts blow away the Fitzgerald's radar antenna, right? If you can't imagine things getting any worse, now you lose your radar, right? And of course, what that means is that it can't see what's ahead of it. Also, the power at the navigation station at Whitefish Bay also goes out, right? So they don't have contact with the navigation station as well. And at 5 p.m., the lighthouse at Standard Rock, so they have lights so you can see them, also goes out. Which means, as I interpret it, the Fitzgerald is blind, right? right? No radar, can't see lights, can't tell where it's going. And that's why at around 6 p.m., McSorley tells another ship captain that the Swedish vessel Ackerman via the radio, I have a bad list, again, both radars, lost both radars, and I'm taking heavy seas over the deck. One of the worst seas I've ever been in. That to me becomes an important part in terms of how I try and interpret this, is what happened. Because of all the stuff that I read, he's the only captain. And there are a lot of experienced captains on the Great Lake at this time who says, one of the worst seas I've ever been in. And so we'll come back to that. The Anderson is 10 miles behind it. And again, now the Anderson's going to be giving it directions, right? Because it's blind. They can't see where it's going, the Fitzgerald. So that's the important part of them traveling together. At 7 p.m., a main hatchway caved in, and he said, fellas, it's been good to know you. If you know the song, you know he's talking about the cook. The cook is saying that the captain wired in, he had water coming in, and the good ship and crew was in peril. And later that night, when its lights went out of sight, came the wreck of the Edmund Fitzgerald. That phase, again, give him credit, they're a folk singer. It sounds very romantic. I mean, that's one of the nice things about the song, it's a really nice ballad. But the crew had no idea of the danger that they were in. They knew they had some problems, but there were never any distress signals called out. And so they really didn't know what was happening, and I doubt very much the cook said anything like, it's been good to know you. One thing I did notice, that didn't mention, is that this ship, because it was the pride of the American side, its galleyway, where you went to eat, guests always wanted to get on that ship just because it was a big one, but also to get on the galleyway so they could eat there, because the food was really good, particularly in comparison to other ships. In reality, like I'm saying there, the sinking of the Edmund Fitzgerald was so rapid that they likely had no idea at that time, where he's singing that song, of the seriousness of the condition that they were in. They knew they had problems, but not how serious those problems were. To Gordon's Lightfoot credit, he really tried to memorialize the last days of that ship and to get it right. And so he has this phrase, at 7 p.m., a main hatchway caved in. He said, fellas, it's been good to know you. Of course, there's been a lot of investigations of what brought the ship down. When you lose a ship like that, the Coast Guard's going to send out a Marine Transportation Safety Board investigation, and they're going to go down and they're going to look at the ship and they're going to try and conclude, why did it go down? Clearly, it was taking on water. How was that water getting in there? And what the Transportation Safety Board concluded was that the water was getting in through the covers, the hatchways, that they weren't properly sealed. Now, and that's why he used that phrase, main hatchway caved in, right? All the water's getting in there. The families of the sailors, of course, did not like that. Again, there's no eyewitnesses, there's pictures. Of course, they did not like it, because if that's the case, that means the clamps weren't fully sealed. And so who's to blame? The sailors, right? The people who were supposed to clamp that down. Gordon Lightfoot had changed the song a couple of times, changed a few words now and then. He became close with some of the family, particularly Ruth Hudson, who had a son that was on there. So in honor of them and the family, and also, again, trying to be sure he got it right, because not everybody agrees that it was the hatchways, even today. He changed it and said, at 7 p.m. it grew dark. It was then he said, fellas, it's been good to know you. If you listen to all these stations, you'll hear the original version out there, but if you had the honor of listening to him in live concerts after 2010, that he would sing the new version, and that's what he did. And I had that honor. Ann, my wife, and I went to see him. in 2012, I think it was. And he's singing, and of course everybody sings along. You know, you're all deadbeats, none of you are singing. Which may be good, but if you see Gordon Lightfoot in his live show, everybody's singing along. So they're singing this song, and as they're approaching this phrase about the hatchways, I elbow in, and I say, watch this, watch this. And she thinks I'm crazy. But sure enough, everybody's singing at 7 p.m., a main hatchway caved in, and Gordon and his band are singing, or 7 p.m., it grew dark. And so the whole audience gets confused, right? Because they're thinking they lost the words. You know, it's like trying to sing a song that you don't know the words to. So everybody gets confused, and I get very entertained. And then he gets to the next phrase, and you know, he hasn't changed anything yet, so everybody's back to singing, and everybody's happy. But I thought that was nice of him to do that. The other thing he said, and I think we'll get to this quote later on, in a musty old hall is where they had the bell ring. He visited it once. They actually honored him now by ringing that bell, not just for the 29 sailors, but they include him. And when he went up there, he thought, this isn't a musty old hall. It's more like rustic. So again, if you heard him live, he would sing in a rustic hall. So it's good, trying to do it right. At 7:10 p.m., the Anderson gives navigation instructions. Remember, the Fitzgerald can't tell where it is. It's a little worried to make sure other ships know where it is, and it's not going to run into them. To the radarless Fitzgerald, that again is up ahead. It's always going to be ahead of it. And the Anderson's first mate asks, "Oh, and by the way, how are you making out with your problems?" You know, it seems so casual. And the response is, "We are holding our own." And that, of course, is the last words that will come from the Edmund Fitzgerald. Immediately after that conversation, a snow squall moves across the lake. It comes by both boats. The Anderson, with its radar, again, it's 1975 radars. Today's radars penetrate right through these snow squalls. But the radar on the Anderson in 1975 couldn't do that, right? So they lost sight of the Fitzgerald because of the weather that was passing through. And just as suddenly, at around 7:30 p.m., the squall is through. You can see all kinds of visibilities as the Anderson reports. They can see the coastline, they can see other ships, they can see towers on the land, but they can't see the Fitzgerald. It's not anywhere. No lights coming from the Fitzgerald. And the radar blip, which is now working, also doesn't pick up the Fitzgerald. Captain Cooper searches for the Fitzgerald. I mean, how can you lose a 729-foot ore freighter in the middle of a lake in like 10 minutes? Right? That quickly it went down. He called the U.S. Coast Guard at Sault Ste. Marie with his worst fears. "This is the Anderson. I am concerned with the welfare of the steamer Edmund Fitzgerald. I can see no lights as before, and I don't have him on radar. I just hope he didn't take a nosedive." The other interesting thing here, I mean, just imagine you're out there, this big boat just went down in less than 10 minutes, right? The Coast Guard station, they can't get their boats out to do a search. So they asked the Anderson to go back and look for it in 25, 30-foot waves in this kind of storm. You know what they did? They went back to look for it, right? Which to me, again, is another, I mean, I just can't imagine turning a boat like that. I mean, it's not 729 feet long, but it's big. And of course, they went, and other searches have occurred, and the only thing that they had found, besides some other small debris, is severely damaged lifeboats, 2 of them. Actually, 1.5. So this is the half that they found. They didn't even find the other half of that boat. And this is the other one. Remember, look at this, the sturdiness of that boat, of that lifeboat. It's ripped up like that, and they think the reason why is that it was just ripped off its storage area. It wasn't like they tried to launch it. The waves just ripped it off as the boat went down, and that's why it was so damaged. And again, that goes along with the fact that no distress signals were ever issued. Now, they knew they were in trouble because when the Avivar is going by and they're talking on the radio to the Avivar to make sure they're not going to run into each other, the Avivar also hears in the background someone yelling, "Don't let anybody on deck." So again, what did that mean? Is somebody trying to go out there and check something? Trying to, get in a lifeboat? Who knows? We don't know. Right? But we do know that that was recorded. Does anyone know where the love of God goes when the waves turn the minutes to hours? The searchers all say they'd have made Whitefish Bay if they put 15 more miles behind them. They might have split up or they might have capsized. They might have broke deep and took water. So what happened? A lot of theories about what happened. Again, as I mentioned, the Marine Casualty Report. Everybody agrees they were taking on water. The question was, how is the water getting in there? The casualty report concluded that it was getting in through the hatchways, and they had photos of the hatchways where the clamps are not on. In some cases they're ripped off, in some cases they're just hanging there, implying that they weren't ever sealed up. And at about 7:15 p.m., it just, because of that weight. So again, remember, they increased the freeload so that you could take on more load, right? So you're now sitting deeper and deeper in the water. And to me, that's why he said, the worst seas I've ever been in, right? Because you're taking on more and more water. If it's getting into where those pellets are, a couple of things are happening. One is those pellets are actually absorbent to some degree. So some of the water is getting absorbed into the pellets. The other thing is that when you pile those things up, there's a lot of airspace. Water gets in there, it's going to fill the air spaces. I like to think of it as a pile of sand. You take water and slowly pile it, slowly pour it on that sand. That water ain't coming out on the table. It's being absorbed by the air pockets inside the sand. The other thing is that when they fill the boat up, it doesn't mean that it fills it all the way up to the top of the hatchways. Right? It's down below where the top is. So if water is getting in there, it can actually fill up some more. And all that weight is just adding to the boat sitting longer and lower and lower in the water, and eventually losing its buoyancy and its stability because of that massive flooding. And then it just can't get over these 25-foot waves. Here's a drawing of what the ship looks like. There's been a couple of investigations down there. This was from the first investigation. The drawings, the sketches of the Edmund Fitzgerald from the 77 Coast Guard Marine Report. Again, it's in 530 feet of water. And you can see we got one part here, that's the bow, and we got the other part there, that's the stern. The bow is sitting on the hull, and the stern is flipped over on its side. So as we go through these theories, one theory is it hit bottom. And that grounded it out a little bit, that led to taking on water. Well, you can look at the hull and see if there's any scratches there, but you can't look there at the hatches there because it's sitting on the bottom. The other thing I want to point out is the bow. You can see that damage in the bow, which implies that, and it's probably what's happening, is that the bow, when it went in, just rammed right into the surface. And that's what caused that damage. Those are the two parts. If you look at the sketches in terms of how they were orientated, there's the bow part, there's the stern part, and the debris field is that big arc around it. I don't know if I have on there how big that is, but you can see that those two parts of the ship are about 170 feet apart. Also, you can see that this is 275 feet, and that's 259 feet. Doesn't add up to 729 feet, does it? And that's because that whole middle section is disintegrated. When it broke up, whether you can argue it's on the surface or when it hit the bottom, that middle section is completely gone and makes up that debris field in between. And these are the investigations that went down there to actually look at the ship. The last one was in 1995 where they recovered the bell. So that's sitting up in the museum up in, where is it?
Whitefish Bay.
Whitefish Bay, yeah, Whitefish Point. And when they took the bell out and polished it up, they also then put another bell down there to replace it with the 29 sailor names on that replacement bell. So what happened? As you look at all these investigations, the pictures that they have there, modeling theories, there are basically 4 reasons that are still afloat of what caused the sick. That was a joke there. You didn't even. Not that good. There were other theories. One, when it first went down, there was a theory that aliens came and took it away. You know, so some of them don't hold water either. One is the problem with the hatch covers, you know, and that's what the investigation, the Marine Investigation Casualty Report pointed to, that water was getting into the hatch covers, getting into where the cargo is, and not getting out. Another was bottoming out or grounding that could have happened near 6 Fathoms Shoal. That was something that concerned the Anderson when it was following it and tracking it. The captain of the Anderson thought that they maybe got a little bit too close to 6 Fathom Shoals and might have touched bottom. Another one is stress factors or structure in terms of how the boat was built. So there was a maintenance investigation, as they always do for these ships. And one of the things they noted was that there was some issues with the hull, micro cracks and things like that, that needed to be fixed. And of course, the Fitzgerald promised they would fix it during the winter season, right? And they let them go out. The other thing that some engineers are now coming up with is the way that the Fitzgerald was manufactured, built, right? Instead of just building the whole thing all at once, they kind of built a section and then built another section and stuck them together. And there was some concern there about whether or not that led to some weaknesses in the hull itself. And then another one is a rogue wave. You know, in Long Island, where I would go and hang out and go swimming on Fire Island all the time, we have these things called the Three Sisters, and I think you even talk about it on the lakes, which amazes me. And what it'd be would be that, you know, the waves wouldn't be very good for body surfing, and then all of a sudden you'd get a good one, and you had to be in the water, because when that good one came, there were going to be 3 of them. And so one of the theories is that you had waves like that that might have suspended the boat and caused the boat to crack that way as well. And again, we can argue about these a lot, and people do. I was up at this meeting in Duluth. Boy, it was really interesting to hear some of those speakers talk about the other ideas. I think it's a couple of things. Secondarily, it's probably a combination of these, you know, like problems with the hatch covers. Water could have been going in. I mean, photos show you that they weren't totally sealed. Whether or not that meant water could get in or could not get in. Stress fractures were clearly observed prior to it taking off, so they might have also contributed to it as well. Of course, the primary reason is the weather, right? If we didn't have that weather, it wouldn't have gone down. You wouldn't have had 25, 30-foot waves. And so the sinking of that ship, as we've gone back, as I mentioned, we'd like to go and take today's models and look at what happened to these historical events using the observations that were available then. So those satellite images, the 50th anniversary, they weren't feeding into the numerical weather prediction models then. They are now, but we're not going to use them when we do the simulation with the more modern forecast. And this was done and published in the American Meteorological Society magazine, looking at that ship, taking the that storm, taking the observations, putting it in today's model, and doing the forecast. And what that model did was accurately represent what happened to that storm, right? So they would have known what that path was going to be. This is what it looked like when it was really reaching its intensity. The arrows here are representing the wind direction. So you see it's coming right out of the northwest, right along the fetch. And the different colors are representing the waves that those winds would have generated. And this X right there represents where the Fitzgerald went down. And this was the storm conditions at the time that the Fitzgerald went down. And if you can see up front where it went down, those waves were as big as they're going to get. They were 25, 28 feet high. So when the Fitzgerald went down, according to this model, the storm was at its most intense phase. In a musty old hall in Detroit, they prayed in the Maritime Sailors Cathedral. Oh, you can read it yourself, probably better than I can sing it, for sure. And again, that's back to the phase that I showed right at the beginning. Here is the bell that they recuperated from the Edmund Fitzgerald, fixed it up, and now it's up there as a memorial as well. The ship's bell was recovered in that expedition on July 4th, 1995, and a replica was put down with the names of the 29 sailors. And these are the names of the sailors that were lost at sea, their names, their age, where they were from, and what their job was on the ship. And I like to show this because, it is a great mystery, it's a great story, but, these 29 lives, these 29 people will never be replaced. They're lost forever, and the ripple of that impact extended into their families and their extended families as well, as they are not replaceable. The Fitzgerald is replaceable, and that, shipping still occurs. The thing is, it's safer now, right? Because from that disaster, there were changes, right? They're not going to let a ship go down like that without investigating and figuring out how do we prevent this in the future. And it's been well done because there hasn't been another wreck like this since the 75 sinking. So a couple of things with regard to the regulations and the practices. It's now mandatory to have survival suits, so you're not going to try and get into those lifeboats. You're going to put your survival suit on. Depth finders, right? If it was hitting the bottom, let's have a depth finder to find out how close you are. Positioning systems, right? Lauren was the first one, if you remember that name, if you're old like me. Now we, of course, have GPS, right? So you know where you are. If your radar goes out, it doesn't matter, right? You got that. And even if it goes out on the boat, you got it on your phone, right? You can just pick it right up, find out where you are. Increased freeboard, right? Remember they changed that? You're not allowed to do that anymore, right? You got to keep the freeboard at which the boat was designed for. And of course, more frequent inspection of vessels. And not only frequent inspection, more frequent inspections, but they find something wrong, you're not going out until you fix it. And of course, weather forecasting has got better. We were still learning a lot, but in particular, NOAA also changed how they predict wave heights as well, so they're more accurately now. And in fact, it's not just the four things. One of the things we figured out through studies and investigations, it's also the stability of the atmosphere, or the temperature difference between the air above and the lake water. When you have those differences, that could add on another 3 inches to your wave height. Of course, when you're dealing with a 30-foot wave, does 3 inches really matter? But I had to say something about what NOAA did. Of course, our weather forecasting has gotten better. As I said, in '75, that was just the beginning of weather prediction models as well. And we might figured out much better ways of getting data in there, getting new data in there. There were no buoys on Lake Superior. It was just the ships were reporting that. Now NOAA has buoys out there to measure wave height as well as the meteorological parameters, and hopefully that will continue. And to demonstrate that this is, that we have improved our forecast, this is a storm that occurred in November 9th through 11th, 1998. So again, basically the same storm that sank the Edmund Fitzgerald, the same storm in the 1940 Armistice Day storm. Same track, same intensity. In this storm, it was much better forecast. It did not have it, by the way, it did 10 people died because of the weather associated with this storm, but they were scattered around the upper Great Lakes region, usually by blowing debris or things falling on them. But this storm there was one case where somebody was blown into a water body and then drowned. But this storm was much better forecast. And I remember it. I don't know if people were here in Madison in 1998. I certainly was. And when I'd come out of class, I was so excited to be in that storm. And it was great because you had, 50-mile-per-hour winds. And you could lean into it and it would hold you up. And then as I'm doing that, I'm looking at our space science and engineering building, that big tower that has the golf ball on top, which is a radar. And suddenly I start thinking, oh, what's going to happen to that radar dome? Because if you're having 55, 60-mile-per-hour winds, you could easily get a gust of wind of 75 miles per hour. But it was well designed, and that never came down, which is good. This storm also, because the deaths, well, again, it's a loss of 10 people, but it didn't have a big societal impact. It didn't lead to any changes. And one way I like to demonstrate that, the Armistice Day storm, the Fitzgerald storm, the storm that occurred in 1998, doesn't have a name because it was well forecast and we anticipated it well. So with that, I'll just end by the phrase, the legend lives on, and it will live on, I think. And I am happy to take questions, or if people have to go, I'll stay around to whenever to answer any questions. If it gets really late, you may have to buy me a beer to get your answer. But other than that, thanks a lot for coming. Any questions? Yeah.
I was just thinking about those hatch covers, and I would imagine that in these seas as rough as they had, the ship was torquing in all kinds of ways. And I don't know the nature of those slams. But that torquing cause slams to open up. I'm gonna,
That was one of the explanations. So the clamps, with the ship in that water, even if it's not even 25-foot waves, any kind of waves, it's going to twist and turn. And so one of the things is that if there was a lot of bowing, that could rip those C-clamps off. They're special clamps, but they look like C-clamps. Some of the photos, when you look at them, they're not even installed. So they're not damaged, they're just not in place, which brings up the argument of why they thought it was that situation. So it's probably a combination of water getting in because they weren't completely sealed, or because they were ripped off as the boat went back and forth. Yeah.
You spoke about the advancement in radars, you talked about the advancement in sensors, but the past 50 years, considering climate change, what are the changes you've seen in storms over the Great Lakes?
Oh, good question.
what was the question?
The question was, since 1975 or 1998, have we, what changes do we see in these storms? We still get these November gales. We haven't got the storms like, I think 1998 was the last one where you get these really big November gales. And that's not a surprise. If you think back, before that it was 97, and 1975, before that it was 1940. So it's not like they come every year. We get November storms, clearly, but we don't get these really big ones that sank the Edmund Fitzgerald or caused the Armistice Day storm. By the way, if you haven't heard the Armistice Day storm, and then I'll get to your question, you weren't familiar with that. Do you ever see that video of the Ackerman narrow bridge, Galloping Gertie? Same storm. That's what it did when it hit the West Coast. Yeah.
So it was 17 years old when it went down. What was the life expectancy of a ship that size?
The life expectancy of a ship that size, I'll answer it this way. A couple of years ago, I was up in Duluth with some curlers, and we were coming back and docked in the dock. So this is, 2020 maybe 2019. And docked was the Anderson. And I got so excited. And the other guys in the car were like, what are you talking about? I said, that's the Anderson. That's the boat that was with the Fitzgerald. Actually, I've heard that the Anderson is being decommissioned this year.
Hey, how long was it?
So,
How long is the Anderson?
it was, I don't know, and the reason why I don't know is because they extended it as well. So that was also common. You can't make it bigger in terms of width to fit through these canals, because they're 75 feet was the maximum you could do. So what they tended to do was to extend them and make them bigger. And that's why after the Fitzgerald, a couple of years after the Fitzgerald, they ended up coming out with all carriers that were 1,000 feet long. It's a lot of cargo. Yeah.
I'd just like to say that your weather forecasters have done a magnificent job. I started farming in 1979, and I left thousands of dollars worth of crops on the ground. And 10 years later, we were in and out like clockwork because of your forecast. And it's just been an amazing
Yeah. If you ever ask me for a forecast, I'm pulling out this. I'm a satellite meteorology guy. But, you know, again, part of that is, so thanks for that, because it is true. We've worked really hard to make better forecasts, make better models, get that satellite data into the models to make it better. But, you know, whenever I'm thinking about what am I going to do 3 days from now, I'm opening this up and taking a look at it. I mean, I wanted to take my rowboat out today, but I ended up scooping up leaves. But then I looked at it and I said, well, what's it going to be tomorrow? You know, I'm not turning on the radio, I'm looking at my phone. It's like, I'm going to go take my rowboat out tomorrow. Yeah.
Do you know what the settlement was for those 29 families?
I don't think there was any.
Really?
Yeah.
It was owned by Northwestern Mutual.
Yep, which is an insurance company. You know, I think it may have been associated with a, you know, a natural disaster or an accident, because again, we don't know why it went down. So, yeah. Yeah.
In the spirit of what could have, should have, how much time would they have been able to, if they used the southern route, would they have gotten through this?
If they would have used the shut-in route, they probably would have gotten to that Whitefish Bay area. But again, when you look at the model situation, if it had problems, if the Fitzgerald had problems, because, you know, let's say it was maybe not bottoming out or maybe not the hatch covers, but if there were micro cracks and water was getting in that way, you know, what would have happened when it anchors up, but you still have 15, 20-foot waves in that area. Yeah.
General question, kind of piggybacking on the farmer over here. When we watch the news and the weather report is talking about this model and that model, like when snow's coming, and it said the European model is almost always the one that's the most accurate. Are each of those models using different satellites?
No, they're using the same satellite data. We use the European satellites. They use our US ones as well. So it's the physics in the model that's really different. You know, you can't have it rain, so you have to parameterize. You have to say, if you have these types of conditions, then you will be raining and you'll likely be raining this much. And so how you do that parameterization is different between the different models. How you do the physics, essentially. Yeah.
Did the frequency of the waves have anything to do with it? Because I heard that Superior doesn't allow the ship to recover, they just keep coming.
So the authors of that paper in 2006, where they predicted 25-foot waves, I actually wrote to them today and said, hey, do you know what the spacing is between peak to peak in those waves? Because that'll provide another piece of information that I haven't seen, so I don't know the answer to that. Yeah.
When they launched the Fitzgerald at the christening, did they side launch it or did they launch it manually?
They side launched it, and that's where it came down and generated a huge wave, and then floated across where I don't think of it as a dock, but it's full of water. It rolled across and hit the other side, as well. They have videos on that. It's actually fascinating to watch. And again, 15,000 people showed up. So when people tell me Gordon Lightfoot was the one who popularized the sinking of the Edmund Fitzgerald, I always say no. There was always been interest in that ship. He helped by letting people in Florida know that it existed. But Great Lakes, I mean, people around here, by the crowd in it, you just know, no, we have interest in that ship. Yeah?
It's since been declared a gravesite, and there's been no more expeditions since '95. Do you anticipate there ever being more to find out what may have happened?
And so the question was, '95 was the last time down there. Would I think there's going to be another one? I know that there's a lot of arguments right now, people making it's in Canadian waters, by the way, to Canada to go down there. Because today's technologies are so far, it's 20 years since 1995. These technologies are so much better now than they were then, that they can probably put together a better description, better analysis of what happened to those two halves of the boat, or those two parts. Yeah?
If the forecasting that we have today had been in place in 1975, would they even allow the Fitzgerald to sail?
By 1975, so the model is different, nothing else?
Right.
Yes, they would have
What
done
we
it.
know today, using that same model, would they allow them to sail?
Yeah. And I say that on reading about the people who were going out there, particularly Missouri. This was apparently his last year, and we'll read the histories of him and what he was about. It's about money. You got to take as much ore as you can through those locks. You got to set those records, because if you beat what's supposed to happen, you get a bonus. And so I have no doubt that they would have gone. He would have wanted to go anyway. Now, some of the ships, not all the ships went. There were other ships on the boat that did anchor up and not head out into the lake. Yeah.
How was the cargo weight determined, and do you think it was accurate? Should it have been overloaded?
I think it was accurate. I mean, I used that estimate of 26,000 tons. Well, that's what it weighed. What I have heard, and again, I'm going back to this Duluth conference I was at, where a lot of the authors of all these books were there. And in talking to them, what they were saying is, you know what, they always overloaded it. So even though they were supposed to load to a certain amount, they always added more, because time, weight is money. Yeah?
Yeah, I heard they did like 80 trips a year, back and forth. Were there any months that they didn't travel, that you didn't?
In the wintertime. So wintertime is when they would dock, and the Fitzgerald would dock in Toledo, I think it was, where they would go through, winter reverberation. So again, when they found them micro cracks in the hull and they needed to fix them, it was like, okay, when we winter up, that's when we'll do it. Because as nasty as this weather was, can you imagine being out there in the wintertime? Where you now not only have strong winds, you have really cold temperatures, any water that's hitting the boat is going to freeze, and you have ice on the lake. So they wintered up and didn't go out in the wintertime.
Okay, thank you.
If you have any questions, I'm happy to stay around and try and answer them.
You need to pay your bills to Maddie on your way out if you've not paid for your meal and your beers.